For years, scientists debated whether Mars, now a desolate and frozen planet, might once have been a world shaped by water. Ancient riverbeds, dried-up deltas, and polar ice hinted at a wetter past, but skepticism lingered. Much of the supporting data came from orbiters observing from a distance, leaving room for doubt. Some argued that wind erosion or lava flows could mimic the appearance of shorelines. Others dismissed the idea entirely, claiming Mars had always been too cold to sustain oceans. But then came Zhurong, the first Chinese rover to set foot on the Martian surface, and everything changed. What this rover uncovered deep beneath the dusty plains may finally confirm what many dared to hope. Mars might once have had an ocean, complete with tides, waves, and possibly even the ingredients for life. Zhurong began its mission as part of China's Tianwen-1 expedition, launched in 2020 with a bold objective, not just to land on Mars, but to land in one of the most mysterious regions of all Utopia Planitia, a massive impact basin long suspected to have once held water. Unlike previous missions that focused on craters or volcanic landscapes, this mission targeted what could have been a coastline. Scientists chose this location deliberately. If Mars had oceans, this is where one would have been. But speculation was not enough. They needed rock-solid, ground-level data, something no rover had collected before. For nearly a year, the rover journeyed across the reddish terrain, sending radio waves into the ground and recording their reflections. Each reflection represented a boundary between different materials: fine particles, coarse grains, or rock layers. What caught the attention of mission scientists was not just the presence of reflectors, but the angles at which they appeared. Every one of the 76 subsurface layers detected by Zhurong sloped in the same direction, between 6 and 20 degrees. This consistent tilt could not be random. Natural formations like dunes or volcanic deposits tend to slope in multiple directions. On Earth, such structures are commonly found along ancient shorelines. Over time, waves deposit layers of sand and silt at predictable angles, gradually building sloping terraces beneath the surface. Even when the water disappears and the surface erodes, the buried slopes remain as silent records of long-gone tides. When the Zhurong team compared their data with coastal formations on Earth, one region stood out as eerily similar: the Bay of Bengal. The resemblance was so striking that several members of the research team publicly stated that the only plausible explanation was a past shoreline. This meant one thing: Mars, at some point in its history, hosted standing bodies of water large enough to produce wave-driven sedimentation. Not temporary puddles or seasonal lakes, but something persistent, something vast, something oceanic. For the first time, scientists had direct in-ground evidence collected from the suspected basin itself, rather than satellite imagery from above. The weight of skepticism suddenly felt lighter. What was once dismissed as speculative could now be argued with confidence. But the discovery does more than rewrite Mars's geological history, it reshapes the search for life. Coastlines, even more than rivers or valleys, are ideal cradles for microbial evolution. Unlike flowing rivers that sweep material downstream, shorelines provide stable, long-term environments where organic compounds can accumulate and interact. Evaporation concentrates these materials. Energy sources like sunlight and chemical gradients drive reactions, and mineral-rich surfaces act as catalysts. If life ever emerged on Mars, the coastline would have been a promising birthplace. Buried beneath layers of sand and sediment, traces of such life, if they existed, could still be waiting. Yet, this discovery brings new questions. If Mars did once host oceans, where did all the water go? Today, the planet is frigid and dry, its atmosphere too thin to support liquid water on the surface. Some scientists believe the water retreated underground, now locked away as ice. Others think it escaped into space after Mars lost its magnetic field. Some even suggest that chemical absorption into surface minerals captured much of it. Whatever happened, the transition from ocean-bearing planet to barren desert remains one of the most dramatic climate collapses in the solar system. Could the same fate one day threaten Earth? There is also the faint young sun paradox, a long-standing scientific dilemma. Around the time Mars supposedly hosted oceans, the sun was significantly dimmer than it is today, roughly 25% less powerful. That should have made Mars far too cold to maintain liquid water. Yet geological evidence across the planet points to long-standing rivers, lakes, and now confirmed shorelines. If sunlight alone was insufficient, perhaps the Martian atmosphere was once far denser, trapping heat through greenhouse gases. Or maybe geothermal or volcanic activity heated the oceans from below. Some even propose that meteor impacts or tidal forces from Mars's moons could have induced temporary warming cycles. Each theory has strengths, but none fully explains the scale and persistence of the water features observed. As of now, Zhurong itself rests silently. Designed for 93 Martian days, it far exceeded expectations, operating for nearly 358 Earth days before going dormant in 2022. Scientists hoped it would awaken again once temperatures rose, but so far it remains still, possibly covered in fine dust that blocks its solar panels. Even so, its legacy is already secured. With one groundbreaking discovery, it has forced the global scientific community to reconsider long-held views. The debate is no longer about whether Mars could have had water, but how long it persisted, how deep it ran, and whether anything once swam in it. What comes next may depend on international cooperation. NASA had planned to launch a Mars sample return mission in the late 2020s, aiming to bring back physical material for laboratory analysis. But recent funding challenges have pushed the timeline back, potentially into the 2040s. Without those samples, many answers will remain just out of reach. Meanwhile, China is preparing its own sample return mission, potentially setting the stage for a new kind of scientific race less about flags and prestige, and more about unlocking the secrets buried beneath planets. The question that now hangs over every mission to Mars is no longer just whether the planet had water. It is whether it had life. If those ancient shorelines once hosted bacteria or algae-like organisms, could microscopic fossils still be preserved beneath layers of sediment? Could chemical traces of metabolism remain? Could biosignatures be detected using future drills or spectrometers? Some suggest that the next rover to explore the former coastline should carry instruments specifically designed to detect organic residues. Others argue that we need to drill deeper, beyond the radiation-damaged surface into protected layers where past life might have survived. There is even speculation that, if microbial life once emerged, it may not be entirely gone, that pockets of water beneath the surface might still host dormant or slow-living organisms waiting to be found. Such discoveries would change everything. Life beyond Earth, even in its simplest form, would reshape our understanding of biology, evolution, and our place in the universe. It would suggest that life is not unique to one planet but a natural outcome of chemistry under the right conditions. And if life began twice within one solar system, how many more times might it exist elsewhere? Zhurong's quiet wheels have stirred loud discussions. Its findings are a reminder that exploration is not merely about reaching new places but about challenging assumptions. Mars, once seen as lifeless and static, is now viewed as a world with a complex past, a world that may have once looked uncannily familiar. A world where waves may have crashed against shores, where tides shifted under twin moons, and where life might have flickered in salty pools beneath a younger sky. Let us know your thoughts in the comments below. And if you found the video interesting, don't forget to like, share, and subscribe for more exciting content. Thanks for watching.